In this video, we're going to talk about how do we check dictionaries for equality, how do we merge them together, and how do we generate new dictionaries using the dictionary comprehension, something similar to what we've done with list comprehensions before. So over here, let's say I have a dictionary with a key of A with a number of 1, as well as the key of B with the number of 2. And we have another dictionary where it's quite the opposite. I'm going to just put them in a different order. It's basically the same values, same key value pairs, only in a different order. So let's just rename that. So we call it B. Here's A and here's B. If I print them out, that's what we get. Now we can compare them using the double equal sign. So we are checking, does A equal B? And the answer is true. It doesn't really matter what the order of your items in the dictionary is, as long as they have the same keys and value pairs, they should be equal. However, what you should note is that they're not identical, meaning that in memory, we are not storing both of these variables in the same spot. They are two different items in the memory. So if we check what is the ID of A and the ID of B, and let's print both of these. We know that they are two separate items. So how do we check for the identity, not just equality? That is where we would use the keyword is. So I could do is A equal to B? Are they equal? And that should return false because they are not the same. A is not B. So just keep in mind, equality is not the same as identity when you're checking your dictionaries here. So keep in mind the insertion order does not matter and equality is not the same as identity when it comes for your checks around dictionaries. So we could use the double equal or the exclamation point equal to check for the non-equality. So this should return false. And this obviously you can combine it with not. So A is not B, that should return true. So dictionaries here are able to use, or they support the double equal or the exclamation point equal. And in those cases, the insertion order does not matter. Also, that identity does not equate to equality when it comes to dictionaries. So they could be two identical items in terms of their values, but they are not the same variables when it comes to where they are being stored in memory. Now let's talk about how do we merge dictionaries in Python. Let's say I have a dictionary here. I'm going to call it base, and this will have a host of localhost and a port of 8000. And let's create another one that we're going to call override, which we're going to use to override the values in the base. And let's say in this case, I'm going to override the port value. So it is 8080 instead of just 8000. And this is going to be with a property called debug equal to true. Now, a non-destructive merge, meaning that we would not be overriding or mutating the original values, would look something like this, where our merged would equal base and then union override. If we print out what that looks like, we get back the host is localhost. That has not been overridden. The port has been updated, and we also merged in, or we added in, an extra key or an extra item here, which was the debug, and that equals to true. If I print out what my base and override were, you see that they have not been touched. They basically are intact, has not been updated. Now we could also update the base in place. So basically override or apply those changes onto the original base variable. And we could do that in one of two ways. We could do base dot update, and then we can provide the new dictionary. If I run this and print out what my base looks like, here we go, we get it merged. Let me go back and reset those values just so I can show you the other way of doing that. Here we go. So we get base in the original state. We could also do base, and we'll do the augmented assignment here, this time with the union operator, and that should equal to the merged value. So over here we looked at 3 ways that you can merge your dictionaries together. One is a non-destructive way, which basically means you do not change the original values, and you only need to use the union operator. We could also use the update function, and we could also use the augmented assignment using the union operator to basically apply whatever those changes are onto the base variable. Earlier, when we talked about list comprehensions, we talked about how it is a convenient notation to create new lists using a expressive single line statements that basically define what this list would look like. We could do the same thing in dictionaries, and it would look something like that. The simplest one could have squares equal. Here's the pair. It's going to be the n, and the n raised to the power of 2 for n in range of up to 5 or up to 6. If we print out what squares look like, here we go. We get our dictionary where the keys are numbers and the values are also numbers. So 0 is 0, 1 is 1, 2 is 4, 3 is 9, 4 is 16, 5 is 25. Obviously, we can change this so it starts with the number 1 instead. That way we can skip the number 0 as well. We could also have something that looks like this, where if I have a list of words like data is beautiful and messy, we could create a words length dictionary where it would be word and length of word for W in words. And if we print this out, you would get the following. We could also do conditional filtering, where we would say only return the words that are more than 4 characters. So if the length of the W is more than 4. So now if I run this, we only get back beautiful and messy. So again, the format here is that you start with your curly brackets and whatever the pair of values are going to be, where the first item is going to be your key, the second item is going to be your value, and then you put in whatever the for loops or the nested for loops or the conditional filters here, and that gives you a new dictionary defined in what we call dictionary comprehensions.